Okay, good morning again, everyone. Now, can people hear me okay?
Yeah, we can hear you.
Good. So I actually just want to briefly talk about one aspect of the assignment specification because I've received one or two queries in relation to the branching policy that you have to follow, which is outlined here. Now, to again explain it, I haven't really gotten any questions in the labs, but one or two people have contacted me on Teams. So rather than explaining it in the labs, maybe I'm just going to explain it here once more to you. So everybody has seen this slide, so there's nothing new there, hopefully. So to try and explain it again, this is what I've prepared, if you like. So what I'm showing you here is the typical kind of sequence that you are going to be doing in relation to your Git interaction, or the Git version control practice, as I'm calling it there. So the main thing you need to remember is that anytime you are going to be committing, then you always have to be on the develop branch. So maybe the very first thing you should do when you sit down to start to do some work on the assignment, whether it be this assignment or the web app dev assignment, is just make sure you're on the develop branch. So either do a git status or do a git checkout to the development branch, to the develop branch. And so you're on the develop branch, you do your editing of your files, whatever you're doing, whether it be writing React code or tests. You commit that work. Maybe you're running the app and you're running your tests in here as well. You do a commit, maybe you do some more work, you do another commit, you stay inside here. Then eventually you should push your develop branch up to GitLab. And of course, in doing that, that's now going to trigger the execution of your pipeline in GitLab. Now, from the previous slide, the pipeline associated with the develop branch, actually all it's going to do is install the various dependencies and run npm build. So it's going to build some bundles for your app. It doesn't do anything else. That's what I prescribed on the previous slide, that the develop branch, whenever you push to the develop branch in GitLab, the pipeline just does two things really. It installs the dependencies and runs npm run build. Maybe there might be an issue. If there is, then you come back. You make whatever changes you need to make in order to fix whatever caused the pipeline to break. There shouldn't be really very little that would cause this pipeline to break, because it does very little. But if there is, you make the necessary changes, the edits, you commit, get things right again, maybe run your tests down here or run your app, whatever it is, install new dependencies, whatever you need to do. You push up to GitLab, to the develop branch of GitLab again. That's going to trigger the execution of your develop pipeline. And you're going to stay here until the pipeline passes successfully. And that should, as I said, happen quite early, I think. You continue on. Well, maybe at this stage, assuming you've been doing writing some tests here, what the very next thing you should do maybe is to check out the staging branch and merge your develop branch into the staging branch. You should only ever be merging into the staging branch. You should never be committing while you're on the staging branch. So I'm doing a merge of the develop branch into my staging branch. And every time you do a merge into the staging branch, you should really push up to the staging branch above in GitLab. That's going to trigger the execution of your staging pipeline. The staging pipeline involves everything that happened here, which should be fine at this stage, but also the staging pipeline is meant to run your tests above in GitLab. And again, if there are any issues there, then you fix them. Now, by fix them means you're going to be making changes to some files. So the very first thing you should do is check out your develop branch, because we never want to do any kind of file changes while we're on the staging branch, which we would be here. Check out the develop branch, do your fixing, commits, check out the staging branch straight away because we're on the develop branch now. Check out the staging branch, do your merge, and do your push up to the staging branch in GitLab in order to make sure all your tests are passing. And kind of on it goes. Maybe you want to do some more work. Maybe my tests are passing now up in GitLab and my React app is fine so far. So I'm going to do some more development work straight away. Check out the develop branch and do more of what you've been doing here. Eventually, it would be time after you've merged into the staging branch. Maybe you should check out the master branch as well, slightly less frequently than you would be checking out the staging branch. Check out the master branch and merge the staging into the master branch. You should really only be merging the staging into master. You shouldn't be merging the develop into master. You're only going to be merging the develop into staging. So merge the staging into master, which is really just going to be a fast forward. In fact, all of the merging are going to be fast forwards. And whenever you merge into the master, you should push up to your master in GitLab. Now, for most of you, that will just run the exact same pipeline as before. In other words, it'll run the install, build, and test pipeline. If you decide that you want to try and deploy your React application, then you'll also have a deploy job or stage, sorry, in your pipeline. So that would be an additional stage, but maybe for many of you, it will be the same as the staging pipeline. Also, whenever you push to your master in GitLab, you should also push to your master in GitHub, purely for the web app dev side of things, because it's the repository that you have in GitHub that I will be using when I'm assessing your web app dev assignment. And, this is just repeated many times. Okay, so that's how I see your kind of workflow happening as you're developing your movies app and as you're writing tests in parallel with that. Again, I'll put this up on I've added 2 slides onto the specification for this assignment, and I'll update the assignment specification on Moodle so that you can see this sequence here and just spend maybe 5 minutes or so just studying it to make sure Yeah, I understand the flow that I meant to follow. And this is kind of a summary of what I'm calling the rules that you need to follow. Number one, you always should be on the develop branch before you start typing anything into your files, before you start doing any type of editing. Make sure you're on the develop branch. Never do commits on the staging or master branch, which is kind of the corollary of this. Number three, really in terms of the staging branch, you should only ever be carrying out merge operations on the staging branch and the master branch. Okay, you should only ever be doing merge operations on those. And I probably should have said as well as a rule there is that you should only be merging the develop into the staging branch, and you should only be merging the staging into the master branch. After every merge, whether it be a merge to the staging or the master branch, after every merge, you should do a push to your GitLab staging branch, where I'm being specific here. After every merge to the staging branch, you should push to the GitLab staging branch. After every merge to the master branch, you should push to the GitLab master and to the GitHub master. Okay, so it does seem quite involved, but it's just a habit and a practice that you need to start getting into straight away. Are there any questions about that, I wonder? No. Okay, so I will update this specification on Moodle so that it includes these two slides and you can just study them. And as I say, it is just a habit or routine that you just need to get into the swing of very early on. And once you're into it, then it's just becomes second nature, I think, in order to it just becomes second nature to you and you don't even think about it. Right. No questions?
Oh, that's perfect, Dermot. Thanks.
Okay. So that's that. So back to what we were talking about last week, which is the WebPack tool, but really it's kind of this whole idea of bundling our source code or packaging our source code into bundles. And this is what WebPack does for you. So, you know, this was kind of our visualization of it. We have all our source code on the left here, whether the source code be JavaScript, CSS, SAS files, less files. CoffeeScript is a cleaner form of JavaScript. I probably should have put TypeScript in here as well. So it might be other forms of JavaScript. And what Webpack does is it takes all of these source code modules and it packages them into bundles, which we have on the right. There may be one bundle that contains all your JavaScript. As a minimum, it turns out that there are always two bundles. One of the JavaScript bundles will contain all third-party modules, in other words, your node modules code. The other bundle will contain all of your code. That's as a minimum. But what we'll see later on is that we tend to try and split this up into smaller bundles again for a good reason. There'll also be a bundle that contains all of your CSS assets, although in fact there are a minimum of two. one that will contain all third-party CSS, like our Bootstrap stuff. The other one will contain all of our custom CSS. And again, you can do further splitting on that. You can have bundles as well that contains all images that you might use or fonts, which we don't tend to have in our case anyway. So that's what WebPack does. It constructs these bundles for us. And in the case of a React app and using the Create React App tool, then these bundles we'll find inside in a build folder. And they look something like this, okay? So anything that ends in .js is a bundle. Anything that ends in .css is a CSS bundle. And there are also files that end in .map, which are what are called source maps. And we use source maps to aid debugging of our runtime application. And what the source maps do is they convert a line from your bundle file to the corresponding line of a particular file in your source code file. So rather than getting error messages in the browser saying that there's an error occurred on line 800 of one of your bundle files, that really doesn't mean anything. What we want to be told is that there is an error on line 5 of a particular source code JavaScript file that you have developed, and then you can start debugging it from there. So that's what source maps do. They map from the bundle files back to your source code files. Unfortunately, Webpack just creates those for us. We don't have to do anything. The other thing to notice is that the bundle files, their names follow a particular pattern, okay? And let's take the JavaScript ones. So here's one of the JavaScript ones here. So the format of the bundle file names is, it begins with just a name part, which is kind of, which are kind of predetermined. So the bundle whose name begins with main contains all of our source code. There's another bundle up here that contains the name to, and just by default, that contains all of the node modules code. The second part of the name is a hash value. So there's the hash value there, and there's the hash value there. The hash value is computed based on the contents of the actual file. So I said that the main bundle here contains our source code. So if you make a slight change to any of your source code files and you ask Webpack to recreate the bundle, then this hash value is obviously going to be different. The main part is going to be the same. And then by default, there's a .chunk.js extension to each JavaScript bundle anyway. And oh yeah, sorry, I'm only looking at the JavaScript ones here. The CSS bundles are up here in this one. So these are only the JavaScript ones. Right, so that hash value is significant though, and it has a particular purpose. So I'll fast forward on to here. This is roughly where we finished off last week. So when you're, as we say, when you're bundling your code for production deployment, then you obviously have to be, you want to try and make sure that your bundles are as small as possible, because by doing that, then they take less time to travel across the network from the server to the browser. And that's obviously a good thing. And so how do we kind of achieve better load time performance? And how do we, how is that going to influence our bundling? Well, there's a couple of things to it. One, we've got to make sure we perform minification and uglification. And as I said last day, Webpack just does that for us. We don't have to do anything extra in order to achieve that. Caching is also important because every time I load the exact same React app into my browser, and let's say it's deployed remotely somewhere on some remote server, but every single time I load the React app into my browser, and assuming that the React app source code hasn't changed, then it would make sense that maybe my browser should cache the actual bundles so it doesn't have to keep requesting them from the remote server. And thirdly, then we should aim for what's called code splitting, which I've yet to talk about. There's a certain amount of code splitting already performed by WebPack because I showed you there a moment ago that as a minimum, WebPack will create 2 bundles for your React app, one that contains no modules, the other that contains your source code. So it has split the bundle into 2 sub-bundles. But maybe we should actually take the bundle that represents our source code and split that down even further. And we'll see how to do that. Now, in terms of the caching, well, that's just the minification proof. If you look inside any of the bundle files, you won't be able to make sense of it, but it is actual proper ES5 JavaScript. In terms of the caching, given that I've already said now that the file names, part of the file names of each JavaScript bundle or chunk contains a hash value, and we know what the significance of the hash value is, then here's how we can kind of imagine how caching can be of benefit in terms of load time performance. So what I'm showing you here is an interaction between a browser and a server that's hosting a particular, let's say it's a React app. So my browser requests the React app and it's hosted on foo.com. So it sends a request, and this is the foo.com server, and the server responds back with the index.html for my React app. In that index.html, there will be a link tag to each bundle that's required. And so now my browser is going to request the bundle. So let's supposing one of the bundles has a hash value of 1234, just for simplicity's sake. Okay, so it requests that bundle file and the bundle is returned back to the browser. Now the browser will actually cache that bundle here locally. Later on then, at some later stage, my exact same browser wants to load the React app again. So it sends a request to foo.com. That will return back the index.html. But assuming that there's been no change to the source code, the index.html is going to have a link tag to bundle.1234. The browser though will check, do I have that bundle already in my cache? And it will. So it'll just execute the React app, or it'll start it up. It won't go requesting the bundle all over again. At some later stage, this happens. I make some changes to my React code. I repackage it using Webpack. So now the bundle's hash is 4567. That means that the next time my browser wants to load the React app, requests it, index.html comes back, but now index.html is referring to bundle 4567. That's not in my cache, and I go requesting it. It comes back, and now I cache it again. So it's the hash value that facilitates the caching that the browser does. And indeed, if there are network devices between the browser and the server, which they definitely will, there'll be routers and other types of networking devices, they can also cache the bundles, because if some other browser wants to load foo.com and it gets the index.html and then it has to request the bundle 1234, then instead of going all the way back to the hosting server for bundle 1234, maybe an intermediate networking device will actually have a cached version of bundle 1234, and it can supply it. It doesn't have to go all the way back to the host server. So that's how caching works when you're with this whole kind of bundling idea of web apps. And it's all because of this hash-based naming convention that WebPack uses. The next thing is code splitting. It's another aspect of how we can optimize our React app. Now, by default, as we already know, there is a certain amount of code splitting done, and I'm just telling you here the plugin that actually performs it, which, you know, it's a Webpack thing. We have never looked at Webpack directly, but this is the Webpack plugin that creates the two default bundles for us, main, and the other bundle, its name is 2, as we saw. Don't know why I didn't call it 1, but there you go. So that happens anyway. Now, where we can actually influence the code splitting is by using something called dynamic imports in our source code. So we can't really do anything with the bundle that contains all of the node modules. We can't split that up easily anyway. But what we can influence is the bundle that contains all of our code. And by default, that bundle is the bundle whose name is main. So the objective is we want to split the app's custom code, that's our code, into multiple bundles or chunks. And why do we want to do that? Well, we want the browser to only load the chunks that it actually needs in order to render a particular page. So when the first page that the browser will render is our home page. So the bundle that it gets from the hosting server should only need to contain the components that make up the home page. Any components, any React components that are used in the creation of other pages in our React app, we don't really need those yet. Okay, so what we say is that the browser, it loads chunks lazily or on demand. It only loads the chunks that it needs that contain the actual components, in the case of React, that it needs in order to render a particular page. And what this achieves as well is that the initial bundle that we get is going to be smaller than it would be if the main bundle had everything in it. So it reduces the initial app load time, because we want our kind of home page to load as quickly as possible. And one way of achieving that is by keeping the main bundle as small as possible. So to illustrate this, I'm just going back to one of the apps we developed in the web app development module, if you remember, the Zoom party app, just by way of illustration. Now we know this already from what I've been saying a while ago. Now, so this code splitting is achieved by using something called dynamic imports. But before we talk about dynamic imports, I just want to refresh our knowledge of what are called static imports. And static imports is what we've been using up to now, and it's all you've ever used in any JavaScript development that you've done. And we know how to code static imports. We do it like this here, sorry, okay? We're obviously doing static imports of the node module stuff as well. We don't have any control over that really. But here's how we do static imports of from one of our source code files, importing another one of our source code files. And these, so this is called a static import, and these static imports are resolved, I'm saying they're on top, they're resolved at build time. And so, oh yeah, so because we're only using static imports throughout our code base, then the main bundle is going to contain all of our source code. And when we load our application into the browser, it has to have the main bundle, as well as this one, of course. It needs this one as well. So for static imports, your main bundle contains your entire application custom code, JavaScript code. Okay, so that's how it's been working up to now. What I'm showing you here is a kind of proof of what actually happens when I load my Zoom Party Manager app into my browser, and I've opened up my developer tools, and I've actually selected the network panel in this case, because that's going to show me, amongst other things, it shows me the network activity that happened when I loaded my application into the browser. And if we look at it, this one here, actually, even though it's not obvious, this is the request from the browser to the server to get the index.html. Then this is the request from the browser to the server to get the bundle that contains all of the node modules. It needs that first. This is the request to get the bundle that contains all of my custom code. This one here actually is when my app sends a HTTP request to the random user API, if you remember. And oh, sorry, I misread it. Sorry, I didn't see the detail. It's getting the CSS bundles first. Let's not worry about that. This is where, let's check it now before I. Yeah, this is really where we want to start off our story. Gets the bundle which contains all the node modules, then gets the bundle that contains the JavaScript. Then it makes the request to the random user API. And that's okay. That's just the favicon icon. So, and this network tab is going to be useful now later on as well. So that's the network activity between my browser and my hosting server. My hosting server in this case is just localhost, obviously. But we're still in the static imports kind of world, right? So I guess what we want to do is we want to try and reduce the size of this guy here. Now, where dynamic imports really become useful is when you've got a multi-page application. This isn't a multi-page application, as it turns out, but I'm just using the simplest kind of app to demonstrate how we actually implement dynamic imports, even though using dynamic imports for this particular app isn't really going to benefit us at all in terms of load time performance, because it only has one page and we need all the components in order to have this page rendered anyway. So just kind of conveniently ignore that for now. So dynamic imports as opposed to static ones, dynamic imports are actually resolved at runtime. Okay, that's a distinction from the static. And React has actually made it very easy for us to implement dynamic imports. If we were doing this maybe 3 or 4 years ago, it would be a lot messier in terms of how we code it. So fortunately, the React framework comes with a function called lazy. And this is how we use it down here. So this is where I'm now importing my friends list component. And I'm importing it by calling a function called lazy, which is part of React, as I said. And the lazy function, you give it a callback, but the callback just has one line of code. It actually has the import statement that you would have used if you were doing static importing. Okay, so it's kind of boilerplate, really, in a way. So what I'm importing here is a component. And so I'm going to be using that component down in the return statement of this component here, which is the app component. And what's really nice about the lazy function, which I'm saying up here, is it lets you render a dynamically imported component as a regular component. So there's very little difference to our JSX when we're using dynamic imports as opposed to static ones. Very little. There is a little bit of a difference though, but not a whole lot. Now, because I've got a dynamic import here as opposed to a static one, when I run npm run build on my application, I'm showing you over here that it's actually going to have 3 JavaScript bundles this time. Previously, it only had 2. It's still going to have the, I'm going to get it right this time. It's going to have this bundle, which contains all the node modular stuff. That hasn't changed. It still has a main bundle, but in addition, it has another bundle, which it just arbitrarily gives it the number 3. And if we had yet another bundle, it would be 4, 5, and 6, and so on. So this is the bundle, I can tell, this is the bundle that actually contains, in this case, it contains my friends list component and any of its child components. Okay, so that's contained inside in that bundle, which means that the main bundle now has all of the other components except the friend list component and its children. I think I say that here. So WebPack creates a separate bundle for each dynamic import. We only have one dynamic import, so there's only one new bundle in our list. And these bundles are loaded on demand. So by on demand, it's whenever it comes across a piece of JSX that needs to use the friend list component, it's only then that it actually sends a HTTP request across the network looking for this bundle. I'll say that again. It doesn't import this bundle as it's doing this here. It only requests the bundle associated with this component when it comes across a piece of JSX that actually uses the component. It does it on demand, or it does it lazily. And so having made that one change to my source code, although there is one other little change, but let's just run with it for now. It now means this is actually what happens in terms of browser to host interaction. Again, first bundle it loads is always, it requests is always going to be the one that contains the node modules. The next bundle it's going to request is main. And because inside in my app component, I use friend list component, it's only then that it requests component number 3. Now, maybe if I just flip over, no, I won't. There is one extra bit of work that you do have to carry out in order for these dynamic imports to work. So here's the JSX for my app component, and it's the app component that uses the friend list component. This JSX here now is the JSX associated with this file, the same file here, what I'm calling the app component. And so here I'm using friends list. Here. And as it turns out, I'm using it down here as well. So it's only when the React runtime, when it's kind of evaluating this, if you like, and it sees friend list component is being used, it's only then that it actually triggers the request to get the bundle associated with that. Now, if all we did was what I showed you on the previous slide, then my actual app would kind of crash. It wouldn't display anything because React is trying to render this and display it on the screen, but it doesn't have this component yet. It's waiting for the hosting server to return it. And so that would mean that my React app would actually crash and my screen would go blank. Now, for that reason, you have to essentially wrap any invocation of friends list, you have to wrap it in a special component called the suspense component. The suspense component is provided by React as well. And what the suspense component does is it provides a fallback piece of JSX that it gets the browser to render while it's waiting for the bundle associated with this to arrive back in the browser. And the fallback JSX that it asks the browser to render while it's waiting is whatever you assign this prop to. And I'm just assigning it to a piece of a H1, but I could have actually another component reference here, assuming that other component is a static import. It can't be another dynamic import because then I'm in kind of an infinite loop kind of situation. So the way the React runtime interprets this is, as it's evaluating this, it sees I need to, because this was dynamically imported, I need to request a bundle associated with that. And while it's waiting for the bundle to arrive back in the browser, it actually substitutes essentially all of this, it substitutes it with this. And so at least something is going to be displayed on the screen while to the user while we're waiting for the bundle to arrive back. Once the bundle arrives back into the browser, then the app goes through a re-rendering, if you like, for us. And now it has the actual component and it renders what I really want this to render. That's how dynamic imports work. So it's a combination of using the lazy function wherever you want the dynamic imports to be, and making sure that you use the suspense function to wrap the dynamically imported or lazily loaded components. And it doesn't really matter. I mean, I could have put this inside the div. It doesn't really, it's not too fussy about where you put the suspense. And of course, there's obviously a closing suspense here. Where code splitting really shines is when you've got multiple pages in your app. And so this is a kind of a fictitious app here. I've got an app that has a root page. It has a /page1 root, and it has a /page2 root. Now, presumably all of the components that are linked to the home page, if you like, all of those would be statically imported.
It's 7 o'clock.
But the components, let's say over here, this component here, the relationship between this component and this component, that could be a dynamic import relationship. And so all of these components would be bundled into, would be packaged into their own bundle. And that bundle would only be requested when the user tried to navigate to this page. And the fallback that would be associated with the suspense component would just display some default kind of page while we're waiting for the bundle to arrive. Similarly, we can have all of this stuff dynamically imported or lazily loaded. And in the lab, this is what we do. In the lab, I take this very simple kind of shell application, which we actually came across when we were doing, talking about routing. Because, you know, all of the components associated with all of these pages here and this page here, none of those components need to be contained inside in our main bundle because we don't need them until the user actually decides to navigate to them. So in the lab, that's what we'll do. We'll take this application and we'll add dynamic imports to it, and we'll prove to ourselves that the main bundle is going to be fragmented into multiple smaller bundles, and main also reduces in size as a result. Obviously, you know, if you had nested roots, which it looks like I have here, right? I have these two nested roots within this root. That's actually something that occurs in the Movies app, you know, where we have the movies detail page. And if the user clicks the show reviews, then essentially when they click the show reviews, the browser's URL changes to a nested root. Okay, so that would be an opportunity to use further code splitting. So I'm suggesting we should have a bundle that just contains that component and maybe children if it had it, and that component. So now we have one bundle, two bundles, three bundles, four bundles, five bundles for all of our source code, and those bundles are only requested on demand. That's that. There is this, what would be really nice is if we could actually see what are the modules that make up an actual bundle. Remember, a module now is just a JavaScript file. What are the modules that make up a bundle? And if we had a tool that would allow us to do that, then that would allow us to make decisions about, well, this bundle doesn't actually need certain modules that it contains, and it would aid our decision as to how we split our code up into sub bundles. And there is such a tool, and it's called the Source Map Explorer tool. Very easy to use. You just install, you do an npm install, and you run this tool from the command line, or alternatively, you put an entry into the package.json script, which just essentially what it does is it gathers up all of your bundles and it gives you a visualization of the internal contents of a bundle. And that's what I'm showing you here on the screenshot. When you run this Source Map Explorer tool from the command line, it will fire up a tab in the browser. And on the top left, it'll have a drop-down menu. The drop-down menu will contain all of the JavaScript bundles that it found for your project. And if you select any one of them, it gives you this kind of what's called a tree map representation of the contents of the bundle. And each box here corresponds to a source code file in your project. I think this is actually, I ran it on the Movies app. So you recognize some of the file names here associated with the Movies app. So what this tool allows you to do is, I'm saying it allows you to see what's inside a bundle. Well, that's fine, but if that's all it does, then there isn't really a whole lot of use to it other than it's just interesting. The second point there is it allows us to identify the main contributors to a bundle's size. Typo there on that line. So if we see that there is a particular file within a bundle that's consuming a large part of that bundle's size, then maybe we might decide I should actually split that module up into smaller modules if that's possible. And maybe those smaller modules don't actually have to be contained within the bundle that I'm looking at. They could be put into sub bundles. The third point there, there's this term called tree shaking. Now, this only applies to third-party modules. Now, I did say earlier on that we really don't have any influence over the bundle that contains the node modules code, but in fact we do, because what we can do is perform this thing called tree shaking on third-party modules if the third-party module actually supports tree shaking. Now, what is tree shaking? The idea is if it's, and I'm showing you an example of it down here, maybe. Here I'm using the Lodash module, third-party module in my code, but I'm statically importing the entire library, if you like, the entire Lodash library. It turns out that when I looked at my use of Lodash, and this is actually back to the Movies app again, when I looked at the Movies app and my use of the Lodash third-party library, there was actually only one particular function within that library that I needed. So instead of doing this import, it has to be static. You can't be dynamic because we don't have control over the library. Instead of doing that import, I changed my import to look like this. The particular function within Lodash that I happened to be using was a function called truncate. And the Lodash library, because it supports this thing called tree shaking, it allows me to specify over here exactly which function am I importing. Rather than the entire library on the left, I'm specifying a particular subset of the library. And it looks like, you know, it's the truncate part of the library. And by doing that, what WebPack will do when it's actually creating your bundles is it will only include this part of the Lodash library in the bundle that it creates containing all of the third-party modules. So instead of including the entire Lodash library in that bundle, it will only include this part. In other words, it has left out all of the other parts of it. You know, I mean, we know what the idea of tree shaking is. If you shake a tree, then the dead leaves fall off. The dead leaves in this case are that part of Lodash that I don't actually need. Now, this only works if the third-party library that you're using supports tree shaking. Many of them do, some of them don't. And all I'm showing you down here is that by doing that, I reduced the, I think it was it's bundle number 2, which is the one that contains my node modules. I reduced it from, that they should be the other way around really. I reduced it from this size to this size. So it was a massive reduction in the size between the two. And that's really something that you're trying to do as well when you're doing bundling, as well as code splitting. You're trying to, and really it only relates to the bundle that contains your third-party modules. You're trying to take out from the bundle stuff that you don't need. Now, we don't do this in the lab actually, but it's important just to be aware of this term called tree shaking and how it's related to this whole area of bundling. Right. I was hoping to do a little bit of demonstration of this as I was talking my way through it, but I realized I was kind of running out of time. So there is a new lab on Moodle, which allows you to kind of practice this bundling and code splitting in particular practice. So that's really for next week. People can have a look at it now if they wish. Okay, that's it for today. Next week, I go back to the whole area of testing and we'll start looking at API testing, because APIs are what you are doing currently in the web app module. So we will just write some automated tests for a web API. There's not going to be a whole lot new. A lot of the stuff that we already know, like Mocha, Chai, all of that stuff comes back into play again. So it won't take us long to get up and running, writing automated tests for a web API, I think, and that'll be there'll be a lab accompanying that. Okay, that's it for today. So I will talk to you again on Monday. Bye for now.
Thanks, Norbert.